The Perseverance rover, currently en route to Mars and landing in just 2 days, this rover will gather samples of the surface of Mars and scan for signs of past Martian life. Launched on July 30th, 2020, this $2.4 billion program consists of the Perseverance rover and a Mars helicopter called Ingenuity, with an expected operational lifetime of 687 Earth days. The Perseverance launched on a United Launch Alliance Atlas V 541 rocket, 5-meter wide fairing, 4 solid rocket boosters, and 1 Centaur engine. After launch, Perseverance started the 213-day, 309 million mile journey to Mars. Once it nears Mars, it will begin preparations to land by entering a collision course to Mars' surface. After cruise stage separation, it will begin its entry, descent, and landing, or EDL phase, as it hits the atmosphere, traveling at approximately 12,100 miles per hour. For reference, a 5.56 round from an M4 carbine travels at only 2,000 miles per hour. Even with a thin atmosphere, the Perseverance landing vehicle configuration comes equipped with a heat shield to protect the cargo from temperatures of up to 2,370 degrees Fahrenheit, almost hot enough to melt steel. During this descent, rockets on the back of this aeroshell will guide the falling vehicle towards the landing site, Jezero Crater, where scientists believe lie the greatest chance of finding evidence of past life on Mars. This controlled descent will slow the vehicle down from 12,000 miles per hour to only 940 miles per hour. It is at approximately this point the vehicle will deploy its parachute with the aid of a range trigger, a new feature differentiating Perseverance from its 2012 cousin, Curiosity. This new system will actively track the vehicle's position on Mars and accurately time the deployment of the parachute, thus more accurately landing the craft in the desired location. After parachute deployment and experiencing a neck-snapping 9 Gs of force, the heat shield will be dropped. 90 seconds after the heat shield is dropped, the rover itself will separate from the back shell and parachute, entering another freefall. After briefly falling, the spacecraft will then ignite 8 retro rockets on the descent stage to begin powered descent, similar to what SpaceX does with their Falcon 9 booster landings. These rockets will slow the craft down to a respectable 1.7 miles per hour by the time it reaches about 66 feet from the surface. It is at this point the craft begins its sky crane maneuver. While still firing the retro rockets, Perseverance and Ingenuity will be lowered below the descent vehicle with a 25-foot long nylon cord. This will be done to avoid the rockets kicking up dust and debris and damaging the rover and its science experiments. This crane-like vehicle will continue its slow descent until it detects Perseverance has touched down, at which point the cords will disconnect and the descent vehicle will fly away from the rover and crash into Mars' surface. Once on the ground, the vehicle will have a lot of science to do. Some of the tools included are the mast cam, the super cam, the Pixel, which is a X-ray specific spectrometer, the Sherlock, which is the first ever Raman spectrometer on Mars. That's Raman with an A and not with an E. And also my favorite, the MOXIE, or the Mars Oxygen In Situ Resource Utilization Experiment, which uses extremely high temperatures to convert the carbon dioxide atmosphere into oxygen, which is necessary for future missions if humans ever want to breathe or make fuel for their rockets. Among many more different instruments, all of these will be powered by a radioisotope thermoelectric generator, or RTG, a device that converts the heat given off of 10 pounds of decaying plutonium-238 into over 900 watts of electricity, and that can last for at least 14 years. This is the same thing that Mark Watney used to keep himself warm in the movie The Martian. Riding along with Perseverance will be a small 4-pound helicopter called Ingenuity. This drone carries no science experiments, but is an experiment itself. With flights lasting up to 90 seconds, it will provide data on flight possibilities on Mars, given that Mars' atmosphere is only 1% that of Earth's, as well as assisting in mapping out potential routes for Perseverance to take. With all these tools, Perseverance has the potential to further humankind's knowledge of not only Mars, but the creation of the solar system as well. It will assess ancient habitability, seek for signs of ancient life, particularly in special rocks known to preserve signs of life over time. gather rock and soil samples that could be returned to Earth by a future NASA mission, and demonstrate technology for future robotic and human exploration. You can watch the live stream for all this happening now. It's already up on YouTube. And also, if you want to read the whole paper that I wrote about this a couple months ago, comparing Perseverance and another Mars experiment from earlier, just let me know and I'll send it to you.